Okay, so this one's just going to be a short video on evaluating trig functions that don't involve special angles, which was what we worked on in the previous video. So, but not all trig functions have to involve special angles. So here's a couple examples where you're asked to evaluate a trig function given some information here. So let's say we know the sine of theta is -3/5, and we also know that tangent theta is greater than 0, and we want to find the cosine of theta. So for these types of problems, what we're going to do is draw a triangle, because think about sine of theta. If we think of sine as opposite over hypotenuse, we know two of the sides of our triangle, and we could always use the Pythagorean theorem to find the third side and answer our question. The first step, however, we have to be careful. We have to make sure we're drawing the triangle in the correct quadrant. Remember, on the previous video, we talked about this acronym that helps us decide where each trig function is positive, and also you can figure out where each trig function is negative. And that acronym was all students take calculus. We know this angle theta, the sine of theta is negative. And according to all students take calculus, sine is positive in the first quadrant because all of the trig functions are positive, and in the second quadrant where sine is positive. But here we're told that sine is negative. So the idea is we know it can't be in quadrant 1 or quadrant 2 because sine should have come out to be positive. So we know we're either in the third quadrant or possibly the fourth quadrant. But that's not enough information. How do we know which quadrant to draw our triangle in? Well, we also know tangent of theta is positive. So all students take calculus. If tangent of the same angle is positive, that could have happened either in the first quadrant or in the third quadrant. So if both of these are true, if we're talking about the same angle, you can hopefully see that this triangle that we're going to draw must be in quadrant 3 because that's the overlap. So then it's just drawing our triangle in the third quadrant, just as if we were drawing it inside a circle like we did on the previous videos. The actual angle theta would always start from 0 and go to here. But as we've seen, finding the sine of theta it just matters about this reference angle right here. So we can go ahead and label the sides from this angle. And if sine is opposite over hypotenuse, this must be 3, and this must be -3 because it's going down. Hypotenuse is 5. We can do a little Pythagorean theorem to figure out what this missing side is. Let me call it x for now. X squared plus -3 squared has to equal 5 squared. This gives me x squared equals 16. So technically x equals plus or minus 4, right, when you take the square root. And actually in this case, since x is going to the left, this is the x-axis, this is the y-axis, we're going to actually have x being -4. And now, once I know that side, I can answer my question. The cosine of theta is adjacent over hypotenuse, so it's going to be equal to -4/5. Let's try one more like that. This time, however, we're given all of the information in terms of the reciprocal functions. Secant we have, and we know something about cosecant, and we're asked to find cotangent. That acronym, all students take calculus, tells us where sine, cosine, and tangent are positive in particular. But you can also use the reciprocal functions. So here would be the idea. If secant of theta is 4, and you can think of 4 as 4 over 1, that means the cosine of theta, since these are reciprocal functions, must have been 1/4. And if cosine is equal to positive 1/4, according to all students take calculus, cosine could be positive in the first or the fourth quadrant. So we have to decide which of those quadrants. If we also know cosecant is negative, less than 0, and we know cosecant is really 1 over sine, well, that means sine of theta must also be less than 0. And sine of theta is positive in the first and the second quadrant, so it can't be in those two, which means sine could be negative in the third or the fourth quadrant. If we're talking about the same angle, then both of these have to be true, then we must be in quadrant 4. So then I can just draw my triangle in the fourth quadrant. Cosine doesn't have to be to scale, so cosine would be adjacent over hypotenuse. I need to figure out this other side here. Let's call it y. 1 squared plus y squared equals 4 squared. I isolate y squared, I get 15. So once again, y would be plus or minus the square root of 15. Since y is going down, we're going to make y negative root 15. And okay, so it's helpful for me if I'm now asked to find the cotangent of theta, and I know that's the reciprocal of tangent, I would just start by writing the tangent of theta, because we're more used to that, is opposite over adjacent, negative root 15 over 1. So therefore, the cotangent of theta is just the reciprocal of that, negative 1 over root 15. On the next video, we're going to talk about some trig identities, which are very, very useful to know in the world of trig. So check out the next video.